OSI model, the continuation of OSI model. You already know that OSI model is more like a model that helps us to understand how information flows from our browser to the internet, and from the internet to, let's say we are the client, or we are a host and on the internet, or maybe in a networking environment, or in a network. So we are sending, for example, a video, or maybe we are downloading a video. So we want to understand how these packets of information that we get from the internet is now understood by our computer and is now being interpreted to us to what we are able to see. It's just like this little communication that we are having here. So I'm on my own end, and I'm the host. I'm hosting the class. So how does information flow from my end? Maybe there's an input device, which is the mic, that records my voice and send it to me, to across the network to your own computer, and your computer gets this information and also interprets it to you and give you the end product so that you can hear what I'm saying. And also your screen can be able to, your screen can also be able to display to you what I'm also showing here in my slides. So the next layer is layer 4, which is transport layer. So this transport layer is known for what we call service to service delivery. You know, we talked that, if you remember, we talked that layer 4 is in charge of end-to-end delivery, and layer 2 is in charge of hop-to-hop delivery. So in layer 4, which is one of the most important layers in the OSI model, in fact, layer 4 to layer 6 can be categorized. There are some models, but it's not only OSI model. There's another model that is called TCP model. But OSI model makes it a lot easier for people to understand. So in TCP model, from the layer 4 to 7 bundled into one, their functionality is somehow the same, and they perform basically the same role. So in transport layer, that's what we call service to service delivery. By the end of the class, we understand what this means. So let's take an example. You are on your system right now. You have the opportunity to open your browser, or have the privilege to open your browser, and maybe your system, it might also be your phone. You can see that you are doing one or two or even three or more different things at the same time. One, it might be on your WhatsApp, exchanging text messages, instant messages with your friend. And we know you will also be playing music at the same time. Then you also open your mobile app, your banking app, to perform a transaction. You see that all these things can happen simultaneously at the same time, and without you mistakenly, maybe when you click on send, maybe you want to transfer money, I want to buy something online, you're performing an online transaction, or maybe you're performing an online banking transaction. You don't mistakenly click a button and that app now misinterpret what you said. Maybe you want to send money and the app will misinterpret it just because you're playing music and switch the music you're playing to something else. So this is because there's a service that is handling that. There's a service that is handling the music you're playing, the music you're streaming online. There's a service that is handling the banking app that you're on. And there's a service that is also handling the chat that you're chatting. Then if you're also browsing other stuffs, maybe you're on Facebook or other, or maybe you are reading news, maybe CNN, or maybe any other news platform. You see that you are doing all these things at the same time without any of them being or colliding with each other. So this is because of what we call ports. There are different ports that handle these things. For example, there's what we call UDP and TCP. So in transport layer, you have two main categories of ports. First, we have the UDP. So the meaning of UDP is user datagram protocol, and TCP is transfer control protocol. So this TCP is a connection-based protocol. So it needs connection for it to function. For example, you are browsing an internet and you clicked on a page. You see that the page must connect properly, and you download, and the page you download everything and display it to you. So that is a connection-based protocol. That is a port 80. Is either you're using port 80, which is HTTP, or you're using port 443, which is a secure HTTP or HTTPS. So these are the ports that handle your browsing assignments. So what it does is that, first of all, TCP will establish a connection. Once that connection is established, it will now allow the flow of packets. So, for example, you're on your browser, your Chrome, Firefox, or any of them, and you log in, you open a web page. First of all, what port 80 does or port 443 does is that it will establish a connection between your client computer and the server computer. We talked about server yesterday in our previous class. So in that server, both of them will establish a connection. And when the connection is established, there will not be a sharing of information. Any page you request now will not be sent to you. So that is a connection-based protocol. Then UDP, that is connectionless. It doesn't need connection. So whatever happens, you might not even get the whole information because it doesn't need connection. For example, you are making a WhatsApp call with a friend, because the port that is in charge of that communication does not establish a connection. It's a connectionless based protocol. What it does is that when there is an interruption, some packets might not be sent properly. That is why if you are on a call, there are some times that the person at the other end will be talking, or he'll be saying some important stuffs, while you at the other end may miss some things he's saying because of poor network. So you see that network has cut the person off sometimes. So that is an example of UDP. And these two ports are up to 65,535 in number. Both UDP is up to 65,535 in number, and TCP ports is up to 65,535 in number. These are two different ports, and they can assign their own numbers specifically to each service that is handling each connection. Like if you can see, as you can see in my diagram, there is UDP that is in charge of chats, and that is port 667. Then there is TCP, which makes use of port 80, and there is UDP also that makes use of port 25,565. You are not going to know all these ports. You don't need to know them. There are very important ports that you should know as a cybersecurity analyst. You should know them up heart. You don't even need to be reminded. It's expected of you as a cybersecurity professional that even if they wake you up in the middle of the night and tell you what is port 53. Okay, yeah, port 53 is DNS. Okay, what is port 443? Port 443 is HTTPS. Okay, what is port 21? What is port 22? Of course, you should know that port 21 is FTP, and port 22 is SSH, and port 23 is Telnet. So this is how you should know all these things. And I think there's another one. Is it SMB? Port SMB. That is port 139. There are so many of them. So it's not the more that you know all these port of heart. You should take it gradually. It's a gradual step, and you get to that level. Then you know those most important ports. And remember, our class is on ethical hacking. So for you to be an ethical hacker, there are some ports that you must know. So whenever you are scanning a website, or maybe you are performing a penetration testing, when you see those ports, you know that, wow, voila, what an opportunity. You know that, okay, this port, I can hack this port, I can hack this port. And you go ahead to target those ports and concentrate on those ones. We will get to that part where we use Nmap and Nessus and the rest of them. So I want us to understand what port does and how they help in communication and the service that all these ports provide. So when we go deep into the practical aspect of it from our next class, so you should have understood that there are what we call ports in networking, and those ports deliver services, and there are services that each port will deliver, and port 80, port 443, HTTPS, and HTTP. So let's go ahead. So this is OSI model layer 4. You can see everything is now coming together. Here, for example, there is you at one end, and you are performing 3 different tasks at the same time, simultaneously, on your mobile device or your PC. So, and your PC have an address that is 1.1.1.1. Remember, in our previous class, we talked about IP address that is a 32-bit of numbers, binary numbers, that are divided into 8 bits. And each 8 bits or octets comes together to form the 32 bits. It is represented in human readable form by, not by binary, but in a decimal notation, whereby a dot is used to separate each octet. So, for example, you see IP addresses like 192.64.58.34. So those are 4 octets that are separated by dots. So this 1.1.1.1 is the IP address of your host or your computer. Then you're performing a financial transaction in, let's say, bank, www.bank.com. The bank can be any bank. Then at the same time, you are on a sports site. Maybe you are watching your favorite sports team while they play. And at the same time, you are also chatting with a friend on WhatsApp. So WhatsApp has its own IP address. The server has its own IP address, which is 3.3.3.3. And the sports channel or the sports site has its own address as 4.4.4.4. While the banking app has its own IP address as 2.2.2.2. Then the service that is there attending to you, because bank is a, a platform that handles people's personal information or personal identifiable information, PII. You call it PII in cybersecurity. So it must be secure. That is why whenever you want to perform any online transaction, it is expected of you to make sure that there's a key in that place that your address bar. There's a key indicating that the website is secure. So if you don't see that key, just know that the website is not secure, that they are using port 80. But if it is secure, they are using what we call a TCP port 443, which is for HTTPS, which is secure HTTP. Then the sports channel, because you don't need to supply your personal identifiable information like your banking, like your address, your debit card information. So nobody cares. You can just log in and stream. They don't make use of the secure ports, the secure HTTP. They use normal HTTP, whereby whether it's secure or not, you just come stream your watch your favorite sports club play, and you can go your way. They don't demand any information from you. They just want you to come and stream. So what they make use of port 80, which is HTTP. Then there is the WhatsApp that's used for exchanging of messages, instant messaging, and instant messaging app, which is WhatsApp. Forget the spelling. So what they use is port 6667. So the server is there listening, waiting for you to demand for connection. So if you open your WhatsApp, your WhatsApp app, that connection, if you take time to load, so what it is trying to do at that particular time is that it is trying to secure that that connection between your device and the server of the WhatsApp, wherever their server is located. And once that is established, you can go ahead to continue your business. Likewise, when you load any website, it first of all goes ahead to secure that connection. And when that connection is secured, you can go ahead. The server is ready to now listen to you to make demands for whatever content you want. So when that happens, the clients now can go ahead and connect with the available ports for whatever service he or she is interested in. Then further on OSI model layer 4, let's say now you are sending a message to you are sending a message on WhatsApp. So what happens here is that this message that you are sending, yesterday we talked about what we call header in packets. So each packet, just like an email that you send, when you send an email, the header of the email will contain your IP address. Sorry, not your IP address. It will contain your email address and the email address of the person you are sending it to. So whenever the person that is receiving the email opens the email, you know, okay, this email is coming from so source, and it is for me. This is my own email, and some other information, necessary information that are available, that is embedded in that header. So, and then there is the body of the email that contains, of course, the actual message, the actual content of the email. So what happens here is that you send a message to one of these servers. Maybe let's say you sent a message on WhatsApp. What happens is that the message will take your IP address and add to it, and also add the IP address of the recipient of the message. And also, in addition to that, it will add the port that is needed for that message to get to or to be delivered to the recipient. For example, you are sending a message using port 80, as you can see in my diagram, on sports.com. So in the header, you see that your source IP address will be there. Then the destination IP address will be there. Then also the port of the service that you demanded for will be there, and your service, also your own host, will also be assigned a port for it to connect to the service. So this is how it is done in networking, or this is how communication occurs in the internet. Then, if you can see here, you see that we are handling three things at the same time. So there is, first of all, the IP address 1111 of the owner, of the host rather, is communicating with port 2222, or sorry, IP address 2222 of bank.com. And this host also have a port open specifically, which is port 8888, that communicates with port 443 of the HTTPS of the bank. So once these two ports are opened and the communication, the connection is sealed, you see that port 8888 from IP address 1.1.1 has been reserved for port 2222 and sorry, IP address 2.2.2.2 for port 443. And that is being done in one phase. And that does not interrupt what is going on, the sports content that you are watching, which also is being done by your host or your device, which is still of the same IP address of 1.1.1.1. And of course, there's another port that is open specifically to port 80 for that connection to go ahead. Then there is UDP port 6667 also, that belongs to WhatsApp, which is the IP address is 3.3.3.3, and that connection is established between your device and the server of WhatsApp. And your device also have also created port 7777 to connect to these ports for that exchange of information to flow. So this is how OSI model layer 4 functions. Then going further, layer 5, layer 6, and layer 7, which are session, transport, and application layer. The difference between these three are not really much. That is why they are bundled in TCP IP model. They are bundled together because they perform similar tasks. Each application chooses to implement this function of layer 6, 7, 5, 6, 7 as they choose. So it is not, there is no specific way that this is being done. So each application will decide how it wants to do this. Then other networking protocols, there's also another model like TCP IP, which combine these layers into one. If you look at here, you see that there is, under OSI model, we have what we call application, presentation, session, transport, network, data link layer, and physical layer. While in TCP model, we have just physical, network layer, transport layer, and application layer. So in application layer, it bundles both session, presentation, and application layer in OSI model into one. So in OSI model, what happens is there is what we call encapsulation and de-encapsulation. So in encapsulation, let's say there are two hosts For example, you and I, we are connected to the internet, and that is me who is the sender or the host or the sender of the message. So what happens is that in my own application layer, in my and presentation layer and session layer, what happens is that this video that I'm showing, this slide that I'm showing, my voice that is being recorded, they are all being gathered together, and it is being sent to the port that is in charge of this communication in the transport layer. So what happens that when it gets to the service that is responsible for this connection, the service will attach the port address of my computer and the port address of the uh, of the website that we are using for this communication. After which, it will now send it to the networking layer, which is my router or my browser. So my browser will attach my own IP address and the IP address of the receiver of this message. Then it now pushes it further to layer 2, which is the data link layer, where uh, the switch will now attach the MAC address of my device and the MAC address of the person that is supposed to receive it. Then it now push it to the physical layer. The physical layer, we all understand, is the cables that transmit data. They help in transmission of data. So when this get into those cables, or maybe in case of wireless transmission, radio waves. So what happens is, you at the other end, your own physical layer, your network, your cable will deliver the message to your network interface card, which is your NIC. When this data gets to your NIC, or your network interface card, the network interface card will read the address to make sure that, okay, this information is meant for this host. And when you look at the address, the MAC address, and be, okay, yeah, this is for this MAC address, it removes the MAC address and forwards it to the network layer. Network layer will look at the IP address of the sender and the receiver also, and make sure that they sync appropriately. And when this is done, the message is now sent to the transport layer for the service that is responsible for this communication, to make sure that we are using the right service or the right port for this communication. And when that happens, that is how you now hear my voice. You now see the data that I'm showing, and every other thing is now being encapsulated. So that is how the OSI model functions. Then the OSI model summary. So what happens here is that each layer, they have their own datagram, and they have their own devices that function at that level. Like, for example, information in physical layer, or in your mobile cables, are transmitted in zeros and one, or bits, and that is what the function of layer 1 is, or the physical layer is. Then the data link layer, which is the layer 2, which uses MAC address as its address system, and handles a hop-to-hop delivery. Is a function that is specifically for switches. Then there's networking layer, or network layer, which deals on IP addresses and routers. There are some routers that also perform the job of the layer 2 and layer 3. Then there is transport layer, which is a service to service ports, and it makes use of TCP, which is connection based protocol, and UDP, which is connectionless based protocol. Then there is session, presentation, and application layer also, which sees to interpretation of the visual transmission of data, or presentation of data to your screen. So that is what the session, presentation, and application layer does. Then you look at some of the important ports that in TCP and UDP. There is FTP, which is port 20 and port 21. You need to know these ports. You're not going to, it's not that you're going to learn them once. It is with time, you're going to know them and what they do. Then there's port FTP, file transfer protocol, which is port 20 and port 21. Then there is port 80, which is HTTP. Then there is HTTPS, which is port 443. Then there is DNS. DNS is domain name server. What it does in a connection is that, for example, you know Facebook.com, you know WhatsApp.com, you know all these other URL, Tesla.com, and so many of them, OpenAI.com, Twitter.com, or X.com. So you know all these addresses. So they are called URL. Computer does not understand this. What computer used to know them is the IP address. So what DNS server does is that it collects this URL and change them into IP addresses, which computer will now understand. So the port for that is port 53. Then there is Telnet. Telnet is used for connection. It's to establish a connection between two hosts, but it is not secure. So SSH, which is port 22, is more like a secure form of telnet. That is why it is called secure shell. That SSH means secure shell. So it is what it means is that any data that is being sent on port 22, which is SSH, is being encrypted. Maybe we'll talk about encryption in our further classes. There's what is called encryption. Those things, those information are being encrypted so that even if there's a hacker at the background that is listening to those ports, they won't get the actual information. They'll just get gibberish information that are not readable because they have been encrypted. You know what encryption is? That's a very simple term. It is also a skill in cybersecurity. Then there's UDP, a connectionless based protocol. So we have ports like DHCP, which is port 67 and port 68. There is IPsec, which is port 500. There is SNMP, which is port 161 and port 162. SNMP is short network message protocol. This is in charge of email. This is port that is in charge of email. You understand? So there's a server that attends to this. We call it there's a server that attends to email or emails being sent over the network. You understand? That is a mail server. So the advantage of learning these ports is that you, as a cybersecurity professional, you may be carrying out a penetration testing, and when you scan a website or you scan a service and you see ports like this will help you to know the port that you go and attack. So there are some ports that you should, when you see them, you know, wow, this is an opportunity for you to attack. It is calling on you to attack. So you have to focus your energy on that. And there are other ports that you don't need to focus on attacking because it will be a waste of resources and waste of energy. You may spend all your energy trying to attack the port, and at the end of the day, you won't succeed. So when you know those ports, you avoid those ports and go for those ports that you can easily attack and get results. So now that brings us to what is cybersecurity. What is cybersecurity? For us to understand what cybersecurity means, there are three areas that we are going to look at. There is confidentiality, there is what we call integrity, and also availability. So these three things form what we call the CIA triad: confidentiality for C, I for integrity, and A for availability. That is the CIA triad. I use a triangle to represent it. So if you are defining cybersecurity, cybersecurity must explain these three things: confidentiality, integrity, and availability. So cybersecurity is the protection of digital infrastructure. Digital infrastructure can be your phone, your mobile devices, even your cars that can be connected to the internet, like Tesla and the rest of them. All those electric cars that are that can self-drive themselves. they use a technology that we call Internet of Things, IoT. So those devices, there is also printers, IP printers, printers that you can connect to the internet, and you can send your documents over the internet to the printer, and the printer will print it. So those are digital infrastructures and the rest of them. So this cybersecurity is the protection of digital infrastructures from threats, threat actors, and attacks, or anything that will disrupt the confidentiality, integrity, or availability of data. Now, let us understand what these three things means. Confidentiality, first of all, this ensures that data remain private. Now, for example, both of us are chatting over a network, and I sent you a message. It is expected that you are the only person that received this message I'm sending. So it has to be confidential. No other person has to see this message. If another person sees this message, that means that confidentiality has been bypassed. So that data is no longer secure. Then another thing is integrity. So that integrity, it ensures that data is not tampered with. For example, I send you a message, go and fetch water. Maybe on WhatsApp, I texted you, go and fetch water. Then there's a hacker that is listening to our communication, and the person will alter this message I sent you from go and fetch water to send me money. I think you are going to do something on man in the middle. We call that attack, man in the middle. So once someone can alter that communication and change the content of the message, that means the message does not have integrity again. The integrity is lost. Therefore, the aim of that message has been defeated. Then there's availability. For example, what just happened now? I was thrown off the network because of my of my poor internet connection. See, I was no longer available. So that is a breach on security. That is a breach on networking. So anything that disrupts this sequence is called a threat or an attack. So threat and attack. So threat and attack in cybersecurity threaten one or more aspects of the CIA triad. So, for example, like I explained, confidentiality. When someone has an unauthorized access to our communication, that means the data that is being transmitted has been leaked. So that leads to what we call data leaks or unauthorized access. The attacks that are under this are what we call phishing, insider threats, or man-in-the-middle attack. Examples are data breaches, credential theft. You know, when someone calls you, there is this popular trend before. Someone will just call you and tell you that I'm from so bank. You have an account with us. I want you to call the numbers on your ATM card. And maybe because you're not aware, you're not cyber conscious, you mistakenly release those information to the person, and the person will use it to perform one threat or the other, or carry out a threat or the other, or carry out a breach in any sense of it. So that is an example of a loss of confidentiality in data. Then integrity, when data is corrupted, when the message that is being sent is not the message that is being received, that means there is an unauthorized modification in that process. So that is where integrity, data integrity is lost. That's what we call SQL injection. SQL injection is uh, a client-side cybersecurity attack whereby an attacker or a threat actor adds some specific strings, maybe to a platform, to alter the database or to have access or to manipulate the database. So it's more like injecting codes that we take, that will mess up the database, thereby giving you access to information you're not supposed to have. So hackers make use of this a lot. So there are examples when financial records are altered, there are fake transactions. This happens a lot. Then availability. For example, there was a downtime right now when I was thrown off the network. That's an example of availability. I wasn't available. So there was a downtime, service disruption. The service that we are enjoying here was disrupted. The attacks that fall under this category is what we call DOS attack or DDoS, distributed denial of service. So this is whereby attackers or threat actors send multiple if demand for multiple. For example, they can flood a website with fake requests, whereby, for example, okay, let me give an example with Facebook. There are some times that the traffic will be too much, or generally there are sometimes a website maybe handling a lot of requests that it won't be available, it won't be reachable to everybody that is requesting for it. So there are some that are being carried out by hackers. They use what we call bots. They hack multiple systems in different locations, and they'll be sending requests from there to attack a particular website or a particular service. Thereby, the service or the server will be attending to those things, thinking that they are real requests. Meanwhile, they are fake requests, thereby disrupting the server from attending to real requests. So, and also ransomware. There was a time that Bet Niger, I think that was 2-3 years ago, we were attacked. Their website were defaced by Russian attackers, by Russian hackers. So their service wasn't available for quite a number of days until they paid a ransom. So a ransomware is whereby a group of hackers come together. They may be sponsored by government. They may be hacktivists. So hacktivists are people that just want to use hacking to push a political agenda or for any purpose. So they come together and make a service or make a website not to be available, or they can deface a website, or they can seize your infrastructure and tell you to pay so amount of money for it to be released to you. Then there's also hardware failure. Also, they can also be seen as an attack. Then examples of that is when websites go offline, service outage. So those are examples of that. Then cybersecurity threats and attacks. I want us to just take a look at some of the threats and attacks that will be necessary for us to understand. First of all, there's what we call phishing attack. This attack occurs when someone attempts to steal sensitive information by pretending to be someone that he or she is not, or by taking the identity of a trusted person or trusted organization. For example, someone will call you and tell you that I'm from so bank, you have an account with us, send us this information. And you, without knowing, you will take the information and they use it against you. Or maybe there will be a time where this happens a lot. I think this has even happened to me not quite long ago. I was on my phone, I received an OTP on WhatsApp telling me that that I'm trying to log in. So that is a phishing attack. Someone was trying to hack into my system and sent a phishing. I said someone pretended to be me and tried to have access to my device. So that is what we call phishing attack. There are different types of phishing. There's phishing. That one is done by SMS. There is a phishing, that is VISH. It is called by voice. That is when you call someone and try to assume an identity that you are not. Especially when hackers call you and tell you that they are from so bank, that they want access, they want to do something or do other thing. Then what we call social engineering. Social engineering is when you get close to someone that is of that holds a sensitive, that have access to sensitive information in a company, and you try to get those information from the person. So that is what social engineering means. When you get close to a person, you get the person to trust you and hand over some relevant information to you. So that is social engineering attack. It comprises of over 60% of the attacks we see online. Then there's man in the middle. So man in the middle when someone is listening to a secure communication, and you both of you that are the hosts that are communicating, we think that it is only both of you are hearing, but there's someone that at the middle interfering with the communication. The person might be silent, or the person might be altering the message that is flowing between both of you, both of the hosts. So when that happens, that is man in the middle. Then there is malware attack. Malware is malicious software. So there are so many types of malicious software: Trojan, virus, worms. There are just few examples. Then there's password attack. We are going to do something on password attack when we go into the practical aspect of our course. We are going to use tools like Buster or GoBuster to look at this. So this is when someone tries to attack your login details by providing some credentials. So when this happens, it is called password attack. Then there is ransomware. I've explained ransomware, and I've also explained the denial of service. Then there is hardware and spyware. Hardware is this normal hardware ads that you normally see. Some of them are malicious, and when you click on it, you don't know if it was set up by a hacker, and there are things like keylogger might be introduced to your system, or maybe there are other malicious malware that may be attached to it, that once you click on it, you don't know that your computer has been infected with virus. So that is it for threats and attacks. Then coming to threat actors and versus threat landscape. Threat actors are individuals or groups responsible for carrying out attacks. These are the hackers that we always hear of. Cyber criminals. These are motivated by money, maybe ransomware, gangs, and the rest of them. Then there's one like nation state hackers. There's a country like North Korea, I think also South Korea, they do this. There's a group of hackers that government are sponsor, and they fund them from the government budget for them to monitor the internet and hack into systems. So those are another form of threat actors. Then there's activists, those that want to push political or social narrative. You understand? Like I don't want to go deep into this because it is somehow controversial. Maybe there's a political ideology or social ideology, for example, LGBT and the rest of them. So that LGBT is a social whatever, so ideologies that people want to push. So there are activists that it is their work to maybe create hardware and rest of them to attack people's system and push this narrative. Then there's insider threats. Insider threats are employees that are not well paid, or maybe employees that are not happy. So they do some malicious things to undermine the security of the company. And there's also script kiddies. Script kiddies are cybersecurity analysts that are learners, hackers that are still learning. So they see a video on YouTube or anywhere and they try the same thing. They try the same script to know what will happen. You understand? They can cause damages without even know the extent of damage that they are causing. So then there's also a terrorist groups, hackers using cyber attacks to cause destruction or fear. Then when it comes to trend landscape, this refers to the current states and evolution of cyber threats, risk, and attacks, method that organizations and individuals face. It considers one, types of cyber attacks, example, ransomware, phishing, and the rest of them. It also has to do with method of attack, maybe social engineering or zero-day exploits. So zero-day exploits are vulnerabilities that are new, that people don't know about, or there is not a remediation to that. So that is why it's called zero-day exploits. So this is also a threat landscape. Then there's the targets of attacks, like cloud. Most now everything is going into clouds. A lot of things are going into clouds. So it is expected that hackers make use of this opportunity to carry out malicious attacks. Then there's emerging cyber security trends. For example, AI-powered attacks. AI is very popular now. So you now understand that people can also make use of that to cause problems, to cause all manner of negative actions on the internet for the sake of financial gain, or maybe to push a narrative. Then threat actors versus threat landscape. I just want us to understand the difference. First of all, threat actors are individuals or groups carrying out attacks, while threat landscape at the overall environment of cyber threat and risk. The focus of threat actors is they are behind attacks, while the focus of threat landscape is to provide platform for attack. They help threats to exist or how the threats evolve. Then examples of threat actors, cyber criminals, nation-backed hackers, hacktivists, and the rest of them. The examples of threat landscape: ransomware, cloud-based, AI-based. So those are the examples. Then scope. The scope of a threat actor is comprised of specific attackers or groups. There are so many of them. There is the Lazarus group, and so many of them. Lazarus group is one of the most popular. Then there's the global, the scope of threat landscape is global security threats and trends. Then different career paths in cyber security. There is Security Operations Center. So Security Operations Center are the people, their roles is to monitor threats and attacks. So they sit in offices, and there are large screens that they look at to read the attacks, to watch signals, and to monitor any transaction that is going to be flagged red. So this mostly banks make use of it to monitor suspicious transactions, and the skills needed for that are SIM tools, Splunk, ELK, QRadar. You're not going to learn all these ones. You're also expected to know incident response frameworks. There are frameworks in cybersecurity. When you talk of cybersecurity career path like GRC, so you need to learn this framework like NIST, GDPR. I think I only put NIST and SAMS. There's also GDPR. There's PCI DSS. So PCI DSS, they handle card transactions like your payment card, your debit card, and rest of them. There's a body that is in charge of handling those transactions to see that maybe a bank that is storing those information are encrypting it so that even when this information gets into the wrong hands, they cannot read those informations easily because they have been encrypted. So what SOC people do is that they monitor log analysis and threat intelligence. Then there's ethical hacking and penetration testers. This is the one that we are going to learn. So they simulate attacks to find security weaknesses. Red team specialists, they conduct advanced simulated cyber attacks. So there's also bug bounty. I also organize classes on bug bounty, but that is an advanced cybersecurity career that deals on web application penetration testing. So these are the hackers that we know. These are the actual hackers, ethical hackers. Someone may tell you that he's a cybersecurity professional, but he's not a hacker. He can be a SOC analyst. The person cannot even know how to attack or what to attack. So the person just monitors frameworks and all that. So, but ethical hacking and penetration testing or penetration tester is a person that simulates attack. Those are the real hackers that are there in the society. Then different career paths also, you have a digital forensic. So digital forensic are the people that whenever there is an incident, or whenever there is something was hacked, so you call them for them to do investigation. They collect samples, they collect digital samples and rest of them to verify the attack surface, what happened, who hacked what, and those how we are they able to hack what. So what they do is that they learn some tools like autopsy. Autopsy is one of the most popular tools that are used by digital forensic, and NCASE, FTK. So those are other tools that they use. So you need the knowledge of autopsy, NCASE, FTK, and also disk analysis. You know, when you throw away your laptop or your mobile device, that memory that is there, it stores even the information, the first information that was stored on that system when it was first bought. But when you go through your system, you have deleted it. But if that information wants to be brought back, the digital forensic experts can bring out those information, even the one that you deleted 10 years ago, 20 years ago, they can also be brought back to life. They use tools to do this. So the people that do this, they use what we call reverse engineering. They use what we call reverse engineering, and also they use a malware to do all these things. So that is for digital forensics. Then governance, risk, and compliance. This is a very cool area in cybersecurity that you don't even need to hack. You just need to read about different frameworks and understand them, and you be an auditor. You just be auditing companies, and you make sure that they are they are they align with what the industry is expected. For example, you will go to their database and check if they do encryption. If you go to how they store their data, you make sure that those things are encrypted, how they transfer their data, what kind of security they use. You know, when data is being transferred, there is a security for it. And when the data is being stored, there's a security for it. So they learn about, they enforce compliance to all these regulations like ISO 27001, GDPR, PCI DSS. There are so many of those regulations also. The skills they need to learn security frameworks like NIST, ISO, CIS controls, and the rest of it. So with that, okay, there's more. There is cloud and DevSecOps engineers. Their role is now that most technology is going into cloud. So they need cloud security people who can secure those infrastructure that is being set up on cloud. There are different cloud platforms like AWS, Azure, GCP, and DigitalOcean. There are so many. I think AWS is the most popular at the moment. So they need security specialists that can handle cloud infrastructure, those equipments or those tools that are being deployed in clouds. So what DevSecOps engineers does is that they are well acquainted with cloud technology, and they protect those digital infrastructure that are in the cloud. So they integrate security into software development pipelines. When you talk of infrastructure as a code, when you talk about infrastructure as a code, so they are the ones that make sure that those infrastructures are secure. The codes that are being run are secure. They test the API, they what we call API, application programming interface. So it is these DevSecOps guys, they test these things to make sure that the tools and the resources that are being deployed in the cloud are secure. So they learn tools like Docker. Docker is a container technology. This is more like outside our class, is beyond what we are learning here. But I just want to give us a hint on that. So then there's Kubernetes, there is a CI/CD security. They make use of Terraform, Ansible. So they enforce security in DevOps. So DevOps is development and operations. It is a cloud platform, a cloud career whereby people now go to cloud and do whatever they want to do and deploy the infrastructures. This is a very deep career. I don't want to go into details into that. Then there is security architect and engineers. Their roles, the roles that are here are security architects. They design secure network and system infrastructure. They design the antiviruses. These are the people that design the antiviruses that we know. They design firewalls that we make use of. These are security engineers. So they implement security solutions like firewalls and IDS and IPS. So what IDS means is